All right, this is lecture, Algebra 2 lecture 4.7 and 4.8, OAS A2N13. The student will perform scalar multiplication. This may be the easiest thing you've ever done. We're going to perform scalar multiplication on a matrix. And so I want to define what a scalar is. A scalar is just a real number that is multiplied by every element of a matrix. So you're going to take a real number, you're going to have a matrix with a bunch of elements in it, and you're going to take that real number and multiply it by every element. And that is scalar multiplication. Very, very simple. Perform the indicated scalar multiplication. Well, here's my scalar. It's a real number, in this case it's a 7. And I'm going to multiply this by every element of this matrix. Well, here we go. I'm going to wind up with this. 21, 28, 0, negative 14, 56, 28, 42, negative 63, and 21. And if I haven't made any arithmetic mistakes, I'm done. I performed a scalar multiplication. I took this real number, multiplied it by every single element. Hopefully I haven't made any mistakes. I'll look to see if I have. Yay! So actually, that's not on there. I'm sorry, I said yay. I'll double check it. Yay! Okay, here we go. I'm going to perform these scalar multiplications. Pretty simple, straightforward stuff. Negative 18, negative 12, 15, 0, 6, 3. I think that one's on there. Negative 18, 12, 15, 0, 6, 3, yay! Here's one that has a fraction for the real number. There's my scalar. I'm going to multiply it by every element here. And here we go. I'll just start multiplying. 3 halves times 7 is 21 halves. Just think of this as 7 over 1 and multiply top times top and bottom times bottom. So this would be 21 over 2. I would just leave it improper because it's just quicker and easier. 3 halves times 3 would be 9 halves. 3 halves times negative 6 would be negative 18 halves. Now in this case, negative 18 halves, this will reduce. So I'm going to go ahead and reduce it. I'm going to call negative 18 halves negative 9. 18 divided by 2 is 9. It'll stay negative. Here's 18 halves. 18 halves is also 9, except it's not negative this time. So I'm going to call this, instead of 18 halves, I'm going to go ahead and reduce it and call it a 9. This gives me, what is that, 54 over 2? 54 halves. That will reduce also. I can divide top and bottom by 2, or I can say 54 divided by 2. Either way I go, I'm going to get 27, if I haven't made any arithmetic mistakes. 3 halves times negative 3 will give me negative 9 halves. That won't reduce. 3 halves times 10 will give me 30 halves. 30 halves will reduce. You can divide top and bottom by 2, or go 30 divided by 2. Either way, you'll get 15. 3 halves times 5 will be 15 halves. That will not reduce. And 3 halves times 20 will give me 60 halves, 60 over 2. And 60 over 2 will reduce. You can divide top and bottom by 2, or go 60 divided by 2. Either way, I'll get 3. And so I took this scalar, I multiplied it by this matrix, and this is what I wound up with. And hopefully I haven't made any mistakes. I don't think I have. And the answer isn't on this one either. I don't know what happened there. Let me just double check it then. 21 over 2, yes. 9 over 2. Negative 18 over 2, which is negative 9. 18 over 2, that's good, 9. 54 over 2, which is 27. I'll double check that with my calculator because it's early and old man's brain doesn't work well. 18 times 3 is 54. Yay, and I divide that by 2 and I do get 27. Yay, okay. Then we got negative 9 over 2, 30 over 2, which is 15, 15 over 2, and 60 over 2. 60 divided by 2 is not 3. 60 divided by 2 is 30. So I did make a mistake. Try not to make mistakes. This is 60 over 2, 30. Yay, there we go. I think that's all of them. That's it. That is scalar multiplication. You can do this.